last week's. All right, now, the next topic here is actually probably 4 lessons from a previous year. And last year, we skipped all of this because we ran out of time. So this is my first time going through this lesson.
Is this 6th grade math?
No, it's a review a little bit, right? All right, so we have a notes page. A notes page. You will be in your book too. You'll go back and forth. I'm gonna have to cut this part out of my video. Should have passed this out before class started.
You don't want them seeing that we have paper?
Yeah, pretty soon I could let someone else pass this stuff out, but not yet. I wish I could do it. Save the time. Welcome. All right, so while I'm passing this out, we talk about 3 different dimensions of figure, of shapes. A one-dimensional shape can only be measured in one direction. Okay, a one-dimensional shape is a line. A line. Okay, a line is a one-dimensional shape. Nope, you guys are going to get a different one. Okay, 2-dimensional shapes, which you've been doing since kindergarten, right? You draw on a piece of paper, a circle, a triangle, a rectangle, a pentagon. 2-dimensional shapes have length. You can measure in one direction and in another direction. That's the 2 dimensions. Okay, length and width. Every 2-dimensional shape has a 2-dimensional measurement associated with it called area, right? How much space it takes to cover it up, like a carpet, okay, or frosting on a cake. Well, frosting on the top of a cake. Okay, every 2-dimensional object also has a 1-dimensional measurement associated with it that you just measure along around the outside, and that is called perimeter. Okay, so perimeter or circumference for a circle is the 1-dimensional shape around a 2-dimensional figure. And the 2-dimensional measurement is area. Well, now we're going to go to a 3-dimensional figure. So it has length and width and also height. So it goes in 3 different directions. Left, right, and back out of the screen. Okay, so 3-dimensional figures have 2 measurements associated with them. The first one is if you just cover up all the outsides of the shape like you're wrapping a present, okay, that is called surface area. Okay, so the word area is a clue. So this is a rectangular prism when I fold it up, okay? And if I unfold it to all of its faces, it has 6 rectangle faces. 3 different sizes, 2 of each size. It has the top and the bottom, that's this big one. It has the front and the back, the long skinny one. And it has the left and the right, the short skinny one. Okay? 3 different size rectangles, 6 faces altogether. The surface area of this rectangular prism is the sum of all these rectangle areas. Right? If you had to use wrapping paper to wrap this up, how many square inches of wrapping paper would you need? Well, you need this face, this face, this face, this face, this face, 6 rectangles worth of wrapping paper. Adding those all together is called surface area. So that's the first measurement we're going to talk about associated with 3-dimensional figures, surface area. So page 666 is in the book, talks about surface area. Yeah, I know, 666. So maybe surface area is just a terrible, diabolic topic. Diabolic, you know what that means? Diabolic means devilish. Right? Okay.
Wait, what do you mean? I'm confused. What do you mean?
It's on page 666.
Is there from
666 is the sign of the devil. Okay.
Then you don't have to do a skip.
Now, So the surface area of a rectangular prism, the book talks about a formula. Okay, oh, use this formula, 2LH plus 2LW plus 2WH. I don't like this formula for surface area. I think surface area is better understood. What? I think that it is better to think about surface area like this, by thinking of the shape unfolded into all of its faces and adding up those different sized rectangles in the case of a rectangular
I know how to
prism.
take it. 6, 6, 7.
Okay?
Why is there a Mr. Yuck?
Because Mr. Yuck is here because I don't think anybody should memorize this formula for the
No.
surface area of a rectangular
Oh,
prism.
God, no.
Right? I think it is much better and easier to think of it as unfolding it. When you unfold a three-dimensional shape like this two-dimensional shape is called a net. You've done these before in previous grades. You used to say, well, if I fold this up, what shape does it make? Right? Called a net. If you think about that and the different sized rectangles, it's way easier to get surface area. Okay? So surface area, this is on your notes page, right? Is the sum of all of the rectangles. Okay? There are, if it is a rectangular prism with length, width, and height all different, right? Then you're going to get three different size rectangles. The top and the bottom. Okay, in this case, that'd be this big one, right? The top and the bottom. The front and the back are the same size. And then the left and the right. So you have three different size rectangles, two of each. So you just figure out what those rectangles are. 2 by 3, 2 times 3 for the top and the bottom, 2 times 6 for the left and the right, 3 times 6 for the front and the back. Okay, and most of the time, these numbers are going to be easy enough for you to just do in your head, and then add them together. The total surface area, the total area of this bunch of rectangles, which is the outside of this three-dimensional shape, 72 square centimeters. Area, squarea. Surface area, squarea. Right? The units for area are square units. It's how many squares it takes to cover up the shape. Surface area. Put this up into, all right, so here's an example in the book, page 666. Okay,
Oh, my.
so find the surface area, and they use the formula, but the formula is really, again, just identifying the three different rectangle sizes, multiplying each by 2 because there's 2 of each, and adding them together and making sure that your answer is in square units. Okay? So find the surface area of these 2 rectangular prisms. The front and the back, that's 6. This length is 6. This length is 10. So 6 by 10 rectangles, 2 of them. 2 times 60. You have the top and the bottom, 3 meters by 10 meters, each of those rectangles, 2 of them. And the left and the right, 6 by 3, length and width. So 18 times 2, 36 for the left and the right. And the total then, when you add them all up, is 216 square meters. The arithmetic on this stuff is not very difficult. This is a special shape. It is not a square, it's three-dimensional. A three-dimensional square is called a cube, but each face of the cube, Tori, is equilateral, and an equilateral four-sided figure we call a square if the angles are 90-degree angles. Otherwise, it's a rhombus, right? Okay, a square. And what is true about all of the faces of this cube? They're all the same, right? So a cube, when the measurements are the same, the height, the length, the width, and the height are all 11 millimeters, Do I have to do 2 times 11 times 11 and 2 times 11 times 11 and 2 times 11 times 11? Do I have to do the front, the back, and the side of it? No, they're all the same. They're all squares, and how many are there? 6. 6 squares. Each one has an area of 11 times 11, which is, you should know that one, 121. So it's 6 times 121. 726 square millimeters.
What? Wait, where'd you get 6 from?
There are 6 squares on a cube, right? So you could do 2 times height, top and bottom, 2 times left and right, 2 times front and back.
I did 121 times 11.
Times 11, there aren't 11 sides on this cube.
Yeah, but that's
It only has 6 sides.
but there are 3 11s.
That's because it's the height and the width and the length, the 3 measurements. Just like this one has 2 and 6 and 3, right? Okay. Other than rectangular prisms, well, so there are real world problems that go with surface area, okay, like wrapping paper, how much do you need to go around a shape? Or if you are painting a room, right? If you're painting a room, how much paint do you need? Paint is bought by how many square feet it covers, because you paint in 2 dimensions, right? And so if you had a whole room to paint, how much paint do you need? How many square feet is the room is a surface area question. It's actually the insides of all these, but without the ceiling, right? So if you had to paint this room, the surface area of the shape is how much paint you buy. So there's real world problems that go with surface area. I don't think we're going to do any of those. And one other discussion here is, what about surface area of prisms that were shapes that are not rectangular prisms? Okay, you're not going to have to do any of these, but just to think about it, this is a triangular prism. What are the shapes of surface area going to be for this triangular prism? How many faces does it have? 5 faces. The 3 sides, these are called the lateral faces. The sides, lateral means side. These are the lateral faces, and then the other 2 faces are the bases. Can you fix your mask, please? And are you chewing gum? Okay.
Does it bother you that people chew gum?
You're not allowed to chew gum in school. Just spit it out. What are the bases of this shape? 2 triangles, okay? So the surface area of this shape is 3 rectangles and 2 triangles, right? So you could measure the areas of triangles and the areas of rectangles and get the surface area of a triangular prism. You can do rectangular prism surface area, you're good to go, okay? That is the end of my discussion of surface area.